right, so we're talking about 4.3. You need notes altogether. And so it's the same process that we've been doing, but the last two sections were one-step equations, and these are two-step equations. So it's important to really write things down at this point and not just do them in your head. So the biggest thing to notice is that we have several operations going on here. We don't have just one. And so when we start to have multiple operations happen, we need to do them in a certain order. And that order is PEMDAS. So we need, anytime I look at an equation or an expression, I need to look at it and go, okay, there's several things going on. So I need to think about PEMDAS. Your brain should, when you're talking about math, should always be thinking about PEMDAS. Okay? Well, my directions are to solve. I end up with 3 steps when I see solve. What are those 3 steps? I heard it. Chop it. When we're solving something, we're chopping, boxing, doing the opposite. We probably need to write that down. We're chopping, we're boxing, and we're going to do the opposite. We're going to do the opposite operation and the opposite order in which we would normally do something. So whenever I see the direction solve, I should instantly think chop, box, do the opposite. And when I'm talking about the opposite order, typically when we are figuring out what order to do things, we start at the top of PEMDAS. When we're working and undoing it and doing the opposite, we actually end up starting at the bottom. We start at the opposite spot. Okay? So if I'm going to rewrite this equation, negative 3x plus 5 equals 2. My directions are to solve, so I'm going to chop it, box it. I'm going to do the opposite. The goal is to get x all by itself. That's the same goal. That was the goal that it was in 4.2, the goal of 4.1. We want the variable isolated. We want it all by itself. So we got to start moving things. So we have to move things in the opposite order of PEMDAS. So you have to look and see, do I have any addition or subtraction taking place in this equation? Yes, I have plus 5. So I'm going to move that plus 5 to the other side, doing the opposite operation. So instead of adding 5, I'm going to do its opposite, which is going to be subtracting 5. So essentially, I'm moving that to the other side, so that goes away. And I have negative 3x still left on this side. And then 2 take away 5 is negative 3. Is x by itself? No, it still has something attached to it, right? We still have negative 3. What operation is happening between the negative 3 and the x? Multiplication. So the opposite of multiplication is division. So I'm going to have to move that negative 3 to the other side using division. So that ends up going away. So negative 3 divided by negative 3 is 1 whole. Positive 1. Before I want to say yes, that's my answer, I want to check it and verify that it's correct. So I'm going to substitute. I'm claiming that x equals 1. So I'm going to come back to my original problem. Negative 3 times x, which we're saying is 1, plus 5. We want to punch that in our calculator. So punch it in and verify it. Make sure it's correct. Negative 3 times 1 plus 5. What does it give me? 2. Positive 2. What was the goal? What did I want it to equal? I wanted it to equal positive 2. So if they equal, I know I did it right. So x equals 1 has to be my answer. Okay? let's look at a couple of these. We still have multiple steps happening, so I'm still thinking in the form of PEMDAS. My directions are to what? Whatever my overall directions say. Solve the equation. So when I think solve, what do I think? Chop it, box it, do the opposite. Okay? Every time I see solve, I'm chopping, I'm boxing, I'm doing the opposite. I don't have enough space here, so I'm going to rewrite it. Chop, box, do the opposite. And that means also in the opposite order. So what do you think we're going to have to move first? The 12, because it's adding 12. So to move it, instead of adding 12, we're going to have to subtract 12. So 4 take away 12, -8. Am I done? Is the x isolated all by itself? No. So how am I going to move that 2? Why is it divide? They're touching. And what operation is touching? Multiplication. So we're going to move the 2 using division. So -8 divided 2, -4. Alright, we're going to do one more together and then let's try one. Got -5c plus 9 equals 16. Chop it, box it. What do you think you're going to move first, Kennedy? The what? Oh, it's -16. Thank you. I did that first period too and I completely messed it all up. Don't forget your negatives. I appreciate it all the time and I forgot it. So what are we going to move first? We're going to move the 9. Why are we moving the 9? Right. It's at the bottom of PEMDAS, and that's where we want to start. So the opposite of addition, subtraction. So -16, take away 9. -25. Got -5c on this side. How am I going to get rid of that -5? We're going to bring it over as division. So -25 divided by -5, +5. I could check it to verify. -5 times 5 plus 9. Punch that in your calculator. I'm supposed to get -16. If I don't get -16, then I did something wrong. So -5 times 5 plus 9. What's it give me? -16, which is what I was hoping for. So I know I did it right. So I know that C has to be 5. Can C be anything else? No. It's the only thing it can be. All right, you try number 3 real quick. So I had 9 equals 3x minus 12. What did we move first? I move the minus 12. How do we move it? What did we do to it? We added 12, which gave me a sum of 21. How did I move the 3? I moved it using division, which gave me, good. Alright, not too crazy different than what we were doing the last time, right? You're always going to move addition and subtraction first, and then you'll do take care of your multiplication and division. Okay? Alright, let's look at example 2. We're still solving, so we're still chopping, we're still boxing, we're still doing the opposite. We're going to rewrite the equation. X over 8 minus a half equals negative 7 halves. Just because it's fractions, does it change what we've been doing? Does it change? No, it doesn't change, okay? Your fancy dancy little calculators will do the fraction stuff for you, so you shouldn't even panic when you see a fraction. So if I chop it and I box it, what am I moving first? It's not negative though, it's minus. Minus 1/2. So instead of minus, we're going to do the opposite, which is going to be plus a half. So negative 7 halves plus a half gives me negative 3. Negative 6 halves, and then it gives me 3. This right here is what ends up tricking people. And if you were to go back to your 4.2 notes, is this variable part of the fraction or touching the fraction? Part of it. And when it's part of the fraction, is it multiplication or division? Division, because this is saying x divided by 8. So that we're going to move the 8 using the opposite, which would be multiplication. So x ends up equaling negative 24. You just have to pay attention with that variable. Alright. Let's look at number 5 together. I've got negative z divided by 3 plus 5 equals 9. What am I going to move first? Plus 5. And so plus 5 minus 5. 9 minus 5 is 4. And so I have this negative just kind of floating out here. It could go to either one. Where do we want that negative to go? Who do we want to give it to? Let's give it to the 3. Let's assign it to the number, because do we know what the variable is yet? No. So instead of giving it to something we don't know, let's go ahead and just give it to the number itself. So we've got z divided by negative 3 equals 4. How am I going to move that 3? We're going to use multiplication, because right now it's doing division. So times negative 3. Get rid of the 3. Which gives me negative 12. Okay? I want you to try number 4 and number 6. I'll give you about 3 minutes. number 4. What did you move first?
The plus 6.
Okay, how did you move it?
Made it 10 minus 6.
Okay. Which gave me a difference of,
4.
how did I move the 2?
We did the, or multiply by 4.
Okay. Which gave me a product of,
8.
so m equals 8. Do y'all agree? Okay. Number 6. We had 2/5 plus 4a equals negative 6/5. Ooh, what am I doing? It's not 4 over a. 4a. Okay. Whew. What do we move first?
The 2 fifths. And you'll do negative minus 2 fifths.
Did anybody move the 4a? I saw some of us move 4a. If I move 4a over to this side, did I help myself in getting a by itself? No, because then I just moved it over to another number, right? So we're trying to move everything away from the a. So the best thing to move here is the 2/5. Now, what sign is in front of 2/5? Because we've been taking the sign in the front. What sign is in front of 2/5?
Positive plus.
It's positive. Okay, so when we move it over, plus 2/5, the opposite of plus 2/5 is minus 2/5. So you have 4a equals negative 8/5. And then to move the to move the 4, what did you have to do?
Negative 8 fifths
Divided by 4. So a ends up equaling. That one's a little trickier because there was a few more things you had to pay attention there. All right. Do 12, 13, and 14. I'll give you 5 minutes to do that. 12, 13, and 14. You probably don't even need 5 minutes for it. Look, we even paid attention to our negatives and so proud. Good. All right. All right, so for the first one, for number 12, we should have got -2. Number 13, we should have gotten -3. And number 14, you should have got that K equals 3.8. Which, as I was spot checking, I think that's what everybody kind of got. Okay? All right, if you turn it over, let's look at number 28 for a second. I'm going to rewrite it so that I have room. So I have -1/3 parentheses 4 plus z equals -5/6. Once again, I have several things going on. So in my head, I'm thinking, please excuse my dear Aunt Sally. Because our directions are still to solve, I'm chopping, unboxing, and I'm doing the opposite. Chopping, unboxing, and I'm doing the opposite operations and the opposite order, which means I start looking for what first?
Subtraction.
Addition or subtraction first. I start at the bottom. Is there any addition or subtraction that I can do here? No. Okay? I can't move that 4 over because it's grouped with those parentheses. Do I have any form of multiplication or division here? What do I have?
The -1/3 times 4, or else
Times the set in parentheses. Let's pretend for a second that set of parentheses equals some number. Okay? Let's just call it 10 for now. I don't know what it is. We'll just call it 10. If it's -3 times 10, what would we move? Or -3 times z. What would you move?
you would do -6 and 5 times.
You would move the -1/3, right? What operation's currently happening with the -1/3? Multiplication. So the opposite of multiplication is division. Now you have to be careful with how you put this in your calculator. What was on this side first? -5/6. So whatever on that side first goes in your calculator first. Whatever you're moving over goes in your calculator second. So we have -5/6 divided by -1/3. So that goes away. So what's -5/6 divided by -1/3?
+5.
Okay. Because I'm done with the multiplication, those parentheses can go away because those parentheses represented multiplication. So now I just have 4 plus z. What do I have to move to get z by itself? The 4. Using what operation? Subtraction. Because right now it's saying basically there's a plus in front of it that we just don't see. So opposite of that is subtraction. So 5/2 take away 4 equals -3/2. Is that what you said? So when you see those parentheses, you still have to remember multiplication. Now there's another one very similar to it. Number 30. I've got negative 2/3, parentheses, x plus 3/5, parentheses, equals 1/2. Chop it, box it. What do I have to move first?
The negative 2.
The negative 2/3. What operation is the negative 2/3 doing right now? Multiplication. So the opposite of multiplication is going to be division. So we're going to move this negative 2/3 to the other side using division. So negative 2/3. So 1/2 divided by negative 2/3. Negative 3/4. I can bring down the part that was in parentheses. I can get rid of the parentheses because I'm done with the multiplication. Oops, not 3/4. Fifth. What do I have to move to get x by itself? The plus 3/5. What operation am I going to have to do to move it? Subtraction. So negative 3/4 take away 3/5.
Negative 47. And 7.
Or you could just leave it like that. Alright, you try practice problems 26, 27, 29, and 31. So try those other 4 problems. 26, 27, 29, 31. So that's a negative. Flip it as a positive. It's not messed you up. Alright, I noticed that a lot of you are not done, but that's okay. Let's look at number 29 because 29 is giving the people the most issues. If I have 2 minus b over 3 equals negative 5 halves, what do I move first? The 2. What operation is in front of the 2 right now? Addition. It's a plus. So when I move it over, I have to move it over using subtraction. So I have negative 5 halves minus 2, which results in giving me negative 9 halves. So I still have this minus b over 3. What am I going to do with that minus?
Put it to the 3.
I'm going to give it to the 3. So now it's negative 3. So I'm moving that negative 3 over using what operation? Multiplication. So times negative 3. So negative 9 halves times negative 3 gives me
27 halves.
27 halves, or if you were to change it to a mixed number, 13 and 1 half. Okay? Number 31. Nobody told y'all to put up anything up yet. I might give you a homework tonight. You don't know that. Alright, number 31. I had negative 9/4 b plus 4/5 equals 7/8. What am I moving first?
The 4.
Using what operation? So when I have 7/8, take away 4/5, what's the difference?
It's negative
3/40. Now I have negative 9/4 v. What operation is happening here? Multiplication. The v is touching the fraction. When it's touching, it's multiplication. So when we move it, we have to use division. We have to make sure we put it in the correct order of the calculator. So I should have gotten v equals negative 1/30. Up top, you should have gotten that G equals -5, and you should have gotten that A equals 4/3. Alright? Okay, now you can pack it up and clean it up.